Hello, today I'm going to be talking about kinematics. Specifically, I'm going to talk about projectile motion and angular projectile motion. So projectile motion problems are problems of an object launched in both the x and y directions that neglect air resistance can be analyzed using physics of horizontal and vertical kinematic problems. The result of a projectile motion is a parabolic path for the object known as the trajectory. So when an object is launched or thrown completely horizontally, the initial velocity of the object is also the object's the initial velocity of the object is its horizontal velocity. Because the horizontal velocity doesn't change, this velocity is also the object's final horizontal velocity as well as its average horizontal velocity. Furthermore, the initial velocity of the projectile is 0. However, this changes a little bit when we look at angular projectile motion. So, for objects launched at an angle, one has to determine the initial velocity in both the horizontal and vertical directions. So you need to break the initial velocity vector up into x and y components in the same manner that you would for components of vectors. So you need to use the components for your initial velocities in your horizontal and vertical tables. Symmetry of motion also applies to the parabola of projectile motion, so that's just something to keep in mind. As well, for objects launched and landing at the same height, the launch angle is going to be equal to the landing angle, and the launch speed is also equal to the landing speed. So now I'm going to apply these concepts of projectile motion and angled projectiles to problem number 21 in my multiple choice section of this APA exam. So the problem reads, a cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly blank. So I'm going to draw what this is going to look like. So we've got the top of a 30-meter high hill. So I'm just going to draw the hill as a rectangle to make the drawing a little easier to visualize. So the projectile motion is going to look something of this sort with an initial at an angle of 40 degrees. So the velocity initial is going to be a vector of this sort, and it's going to be 40 degrees. Oh, and this is the ground below the hill. Okay, so what else do we know? It's shot from the top of 30-meter high hill, so we know that this distance is 30 meters. We also know that the initial velocity is 25 meters per second, so equals 25 meters per second. And lands on the ground below. Okay, so the vertical, so we know that, okay, let's just get right into it then. So the vertical component of motion is a uniformly accelerated motion, as discussed previously. We know that the vertical component of velocity at the topmost point is 0. So velocity there is 0. And so we know that the horizontal motion of the cannonball is a uniform motion with the uniform velocity, u cosine theta. So velocity equals u cosine theta. So we know that velocity initial, I'm going to write this as velocity initial. So we know that velocity initial is 25. We know that cosine, and we know that theta, which is 40 degrees. 40 degrees. So we're going to put that in my calculator. 25 cosine 40, we want to make sure that we're in degrees mode, we get about 19 meters per second, which corresponds to option C. All right, that's it. Thank you.